Hello and welcome to this video. We're going to look at Python C extensions, kind of how they work under the hood on Linux. And yeah, like when would you want to do something like this? Write an extension in C when you can just write Python code? Well, it might be that you want to integrate with some kind of C library, or you want to squeeze extra performance out. Like typically if you have loops or nested loops in Python, they're going to be kind of slow, especially if you have to iterate through a lot of items. So writing those tight loops in C might be advantageous if you do that in the most performance critical parts of your application. So then you can kind of get the best of both worlds of being able to write code mostly in Python where you're very productive and you get a lot done, but for the places where performance actually matters, you're not actually sacrificing that by choosing Python, because you can write these Python C extensions. Other things might be if you want to interact with low-level things directly and you want full control rather than doing it through some kind of library that someone else wrote. But we can get into it. So first we can look a little bit on how does the import system in Python work, because essentially we're going to create an importable module, right? So for starters, let's say we had a file named abc123.py. Then if we start a Python interpreter here, we can see that we can now import this file without any problems. And this module might not have a lot of interesting things about it, but all the modules, they have a underscore name and underscore doc associated with them. You can see the doc here is empty in this case. Okay, like that's even if it has nothing inside. You can see also when I imported it, it created this PyCache folder which contains compiled Python bytecode. It will always do this when you import the first time, which means that the first import is always going to be a bit slower than the subsequent imports. This doesn't actually matter for the runtime performance, so only how long it takes to import, whether this exists or not. But that's enough about Python modules. Let's actually try to see how we could, let's say we just create a file abc123.c and we restart the interpreter and we try to do import abc123. Okay, that didn't work. No module named abc123, so maybe that was a little bit naive, but it turns out it's not too far from how it works. If instead of C here we had .so, which is the extension for shared libraries on Linux, and we try to import it again, you can see now it doesn't say no module named abc123 anymore. Now it actually has a more specific error message because it found this file and it tried to import it. It's saying the file is too short. And well, shared libraries on Linux, they are of a format called ELF, executable linkable format. And this being just a completely empty file is not a valid ELF file, so it's complaining file too short. So how can we create a valid ELF file? Let's try to do that. We just create a new file abc123.c, and we can try to just compile this empty file. Typically you would want to have a main function for regular executables, but for shared libraries you don't need to have that. So to compile it, we can use the GNU compiler, and we just specify abc123.c as the input. We say we want to compile it as a shared library, which means we don't need that main function. And we want to output it to abc123.so. And now you can see we have this file here, abc123.so. And let's try to do the import again. And now we can see, looks like we're on some kind of path here. Now it no longer complained about the file being too short. Now it's saying it doesn't define like this particular symbol or this export function, init abc123. So what would happen if we just created that symbol? We don't need to get the signature correct in order for this symbol to be detectable. That's the thing about C, is that like compared to C++, in C++ all the symbols you define, they will be mangled, which means you can have multiple functions with the same name. And that, yeah, basically so that you can have like one for int, like an addition function for integers, one for doubles, and so on. But in C you can't do that because symbols are kind of globally unique. Anyways, by just defining the symbol, it's going to find it in the elf executable. So for the fun of it, we can try to print out something inside of this function and see if it actually runs. So that we need stdio standard input output.h for, and let's try to print hello world. Okay. And then we can recompile it. And just to show that this symbol actually exists now, we can do readelf symbol, and we can do let's see if I did that correctly. Maybe I didn't specify the file name. abc123.so. And now we can see that this function is exported as a global symbol, which means if we now run Python and we try import abc123, it actually prints out hello world. It ran the function, even though it has the wrong signature here. It ran it, and then it got a segmentation fault. Most likely this is because it was expecting this function to return something, maybe a pointer, and then it didn't, and then it crashed and burned. So how about we, well, assuming it's a pointer, we could always try to return a null pointer, and let's see what happens then. And the void pointer means, yeah, it's any kind of pointer, but one thing all the pointers have in common is that they can be null, so then we don't really need to know the type of pointer. This is assuming it's expecting a pointer to be returned, of course. Maybe it's expecting a number, but this is probably maybe a reasonable assumption. So let's recompile it, and we try to re-import abc123. And now it didn't actually crash. It gave an error, but like the Python interpreter itself is still running and didn't crash. It says error system error, initialization of abc123 failed without raising an exception. So it seems like by returning null here, we're basically telling Python that, yeah, the import failed, but we didn't give a reason or an error message as to why it failed. But then, okay, so what is it that we actually want to return here? What kind of pointer? And turns out, if we look at the documentation, well, first of all, we need to include python.h to get the correct types and functions. We can see for now it fails to import that, reporting a include error. Same thing if we try to compile it now, we get this include error. So in order to fix that, we can start our Python interpreter and we can find out what is this include path that we're interested in. We can do that by importing sysconfig and running sysconfig get paths. And then we look for include, and then we see this is the include directory that we want to use. So we can copy that, and if we run gcc, we can add a dash big I, and then paste this path. And now it worked. It managed to find the python.h header file, and it's compiled successfully. Visual Studio Code here is still complaining, because we only told gcc about this directly, we didn't actually tell the editor. But luckily VS Code here, it has a shortcut where it realizes what the, like, where that file is for us, so we don't need to think about it. So we just click that button and we get this file, and you can see it shows up in here, user include python 3.9. So that's nice. and it no longer complains here. Okay, so now it's possible to recompile it, as we saw with the file with the include path there. Still, it's not gonna be able to import for the time being. So to do that, we actually need to replace this with the correct thing. According to the Python documentation, there is a specific symbol here, pymod init func, which we get from python.h, that we can use as the signature of our initialization function. And that's basically a Python object with py exported symbol in front. Not sure what is this doing, but yeah. Importantly, it's a Python object, and of course we can return null. That's valid. That's basically the absence of a Python object. But what we actually want to return here is module create, and then we want to pass a module definition in here. So let's name it ABC123. We have yet to define this, so let's define it up here. And according to the Python documentation again, this needs to be a struct of type pymodule def, and let's name it ABC123, which is what we used below. And here we go. So what's going to be inside here, again according to the Python documentation, pymodule def head init is the first thing here. Second thing is our underscore underscore name attributes. Third thing, our underscore underscore doc attributes. And then this next one, let's just put it at -1, because I'm not actually sure what this is doing. But yeah, according to the documentation, it's something about interpreter size, and put -1 if you're using global state, whatever that means. It's not important. The default, or like the example, is -1, so we'll just use that. Last one here is our method definition. So this basically defines which methods we're gonna export from the module. We can leave that off for the time being, just to try to compile it at this stage, see what happens, and then try to import it. And we can see it imported without giving in an error, so that's a good sign. And we can do .name, and we can see that this actually is this underscore underscore name. And if we do doc, we get this value here. Just to prove that these are the actual values, let me change this to ABC123 and add some documentation here. This is a module named ABC123. Let's recompile it. Import, and if we do name, we get a new value and the documentation here. So you can see basically these strings end up being returned from name and doc here. Okay, so let's actually create a method as well, so that we can actually run some code there. And to start off simple, we're just gonna create a function that adds two numbers, which we're gonna call add. Very creative. And turns out that all of the Python functions you want to define will have the same signature, which looks like this. And then inside of these functions, you typically have two stages to what you want to do. The first one is parsing the arguments that have been passed. So in this case, we would probably want to have two arguments. Let's call them x and y. And we're gonna assume these are positional arguments. And in the end, we probably want to return the sum of them. So first, in order to convert the numbers from Python to C, we're gonna use a function called pyarg parse tuple. And we're gonna give it the args. And this is a very kind of almost magical string where we say what is the type we expect for each of the arguments. So the first one is an integer, second is an integer. And then we just pass all of the variables here. So the x here, it corresponds to this I, and this y corresponds to the second I. There is a list in the documentation, depending on what type you want to have returned here. There's different letters for all of them, or if there's a Python object you want to get directly, and then parse that object later. Let's say it's a dictionary, you can do that as well. I think you use big O or something like this. Sometimes it's 2 letters instead of 1, but for now we're going to keep it simple and just use 2 I's. And then next up we're actually going to return x plus I, but we actually can't return an integer. We need to return a Py object, which you can see here. So we need to convert it back into a Python object. And turns out you can use pylong from long. So we don't actually have longs here, we use integers instead. But we can just cast it like this. And essentially now we have our add function complete, which parses Python numbers to C numbers, adds them together and converts them back into Python numbers, essentially. Or a single Python number. Okay, and let's compile it, and then Python import abc123. Okay, maybe now we can do abc123.add and 1, 3. But it says that this module has no attribute add, and that's because we actually need to specify the method inside of our module definition. And for that, first we actually create a table of all our methods, which looks like this. Which is a py method def, or a list of these actually. So first of all, this is a list where we need the last element to be null, null, 0, null, according to documentation. And then here we specify what do we want the exposed name of this function or method to be. Next we actually specify a reference to it. So when I just write here, write add here, it corresponds to this one. Third, we write what kind of arguments we give. So you can see there's method var args. There's a few different things we can do here. Fast call, keywords, method, no args, static. Typically I go with var args here. I guess you might want to have keyword arguments sometimes as well, but yeah, let's just go with method var args. And lastly here we can write some documentation for the function. Adds two numbers together. Okay. And now we simply specify our methods inside of our module definition. And that should be all we need to do. A bit of boilerplate here, I have to say. But that tends to be the case when you write C code, that it will have a lot more boilerplate, since like the abstractions of the language is, well, it's not as powerful. You have macros, but it's easy to lose yourself in them if you use them too much. So often it's better to just write things out. Alternatively, you can use something to generate the C code. Python is an example of that, where you write something that resembles Python, and it's used to generate C code instead. And that's pretty good, and you can get a lot of performance from that, but if you want full control over the performance, it's probably best to write it in C directly. Okay, and we try to import it again. And now abc123 dot add. Now we can see. Okay, I actually forgot to compile it, didn't I? Oh, okay. Yeah. So I forgot an equal sign here. Let's recompile it. Okay. And now we can import it. And now we actually have this function, built-in function add. And we can do 1 and 3, and we see we get the result. So what happens if I do 1.3? Well, that's a problem because I passed a float. Let's say that we want to accept doubles instead of integers here. We can actually upgrade our function a bit like this. And then we probably don't need to cast here. Pi float from double. And we need to specify the type here. It might be a D. Let's see if that's correct. And now we can see it works. Okay, that's it for this video. Relatively short introduction. Obviously there's a lot more to go into here, so I might make more videos on this in the future with more complex examples. But maybe this gave you some kind of intuition about how you can write these C extensions for Python.